This video is on multiplying quadratic expressions and factoring quadratic expressions. So first we're going to start multiplying these binomials, and we're going to use the distributive property rather than the acronym FOIL to work these out, because it shows a key step that will be helpful when we do the factoring. So here we're going to start and say that 3x is multiplying x plus 4, and then the 2 is multiplying the x plus 4. So I'm going to start and take the 3x from the first binomial and multiply it by the x plus 4, and then the positive 2 and multiply that by the x plus 4. So now I've set up two separate distributive properties for this problem that had 3x times x plus 4 and 2 times x plus 4. So I get 3x squared plus 12x plus 2x plus 8. And then the middle two terms will combine, and you get 3x squared plus 14x plus 8. So in this next example, we're going to do this same problem backwards and end up with this as the answer. And the steps are going to look nearly identical to this, but going backwards. So the key to being able to factor is to get these two terms, the 12x and the 2x, right, so that the rest of the problem works out. And it's just a little puzzle. And one method that you can use to help organize your thoughts on finding the answer to that puzzle is what I call a diamond. Sometimes it has a box like this around it. That's kind of hard to draw, so usually we just make an X here, but we call it a diamond. So to get the top of the diamond, you multiply the first term times the last term. That's 24x squared. That's 3x squared times 8x, and the bottom is 14x. The key to the puzzle is that you find two numbers that multiply to 24 and combine to 14. Now these are all positive here, so you don't have to worry too much about the signs. But if you think of the factors of 24, 1 and 24, 2 and 12, 3 and 8, 6 and 4, 2x and 12x are the values that solve this puzzle, because 2 and 12 multiply to 24 and add to 14. And then you need the x's to make the variable parts work out. So I need those two numbers, and then I'm going to take this 3x squared, just bring that first term down here. Then I'm going to use the 12x and the 2x from the diamond, and then I'm going to bring down the 8 from up here. So you can see that this whole expression here is equivalent to this expression here if I just combine these like terms. Now I'm going to separate this into two smaller problems and look at these two and these two kind of as two separate problems and take out the greatest common factor out of both of these. So if I do that, 3x squared and 12x, they each have a factor of 3 in them, and x squared and x, both of those terms have a factor of x. So if I take a 3x out of both of these terms, then 3x times whatever I put here needs to equal 3x squared, and 3x times whatever I put here needs to give me the 12x, so it must be a 4. And then 2x and 8 have a factor in common, that is just a 2. And then 2 times x is 2x, and 2 times 4 is 8. And now My last step is to go back to the question, this form of the question. I need two binomials. And once you see this, it kind of pops into your head. It might seem a little bit strange at first, but see how there's an x plus 4 here in both of these? That's one of the factors. And then the other factor is hidden here, the 3x plus 2. So this part here got split up, gets put back together after kind of being split up there. So this is the 3x plus 2. Now if you look at this, we started here, and we went to here, and we went to here, and then we went to here. It's just the exact same steps forward and backwards. The key is that you pick the right two 12x and 2x, the two values here that combine to 14x. And if you look at this, you can see the reason that this will factor by grouping is because the product of the outsides, 24x squared, is the same as the product of the insides, 24x squared. And that's what this little diamond thing does for you, but you don't necessarily have to use it. You just have to be able to think of the pair of values that multiplies to the same thing that the 3x squared and 8 multiply to. Alright, so let's try another example. This might help you see the pieces better. So to figure out the values that I'm looking for, you can use this to help. But basically you need to bring down the 6x squared, and then you need to find two terms that multiply to negative 18x squared and combine to 7x. If this helps organize your thoughts, that's great. Negative 18x squared and combines to 7x. Now I got that 18 by taking the 6x squared and the negative 3x and multiplying those together. 6x squared and times negative 3, and that gives me the negative 18x squared. And then I get the bottom 7x from right here. So this 7x just gets rewritten here. Okay, so then the numbers that make that work are 9x and 2x, and then because they have to multiply to a negative 18, one of these has to be negative, and they have to combine to a positive 7, so it must be the 2 that's negative. Alright, then you can put the 9 and the 2 in either order here. It would be a good exercise to try them either way, but I'm going to go ahead and put the positive 9x here, and the negative 2x here. Again, you could switch these and say negative 2x plus 9x, and the problem will work out the same in the end. So now I'm going to take these two first terms and factor them, and these and factor them. So the number that goes into 6 and 9, the largest, greatest common factor is 3, and x squared and x, the greatest common factor is x. So take out a 3x, and you get 2x. 3x times 2x is 6x squared, and 3x times 3 is 9x. Then the greatest common factor between negative 2x and negative 3 is just a 1. Now, it has to be, whatever this sign is here is going to come down, and there really isn't a greatest common factor here, but you use a 1 when there isn't a larger number available. So negative 1 times what to equal negative 2x? So that'll be 2x. And negative 1 times what to equal negative 3? And that will be positive 3. And see, if you look here, these 2x plus 3 and 2x plus 3 are exactly the same. So since these are the same, I know that I've worked the problem out correctly. If you don't solve the diamond correctly, when you get to this step, these two inside factors will not be the same. And that's how you know that you didn't work the puzzle out correctly. Notice here, these are both x plus 4s in our previous example. Okay, so then see if you can figure out what the two factors will be when we write it in factored form. So one of the factors is the 2x plus 3. I like to write that second, but if you'd rather write it first, it doesn't matter. And then the other factor are the pieces that are remaining out here. 3x and a minus 1. Okay, so factoring is just the going backwards from multiplying. So if I multiplied this out, I could say 3x times 2x plus 3 and negative 1 times 2x plus 3. I would distribute each of these to get these terms, distribute this, get these terms, and then combine like terms to get this. So you're going for fluency to be able to go forward and backward. Multiplying like this, and factoring is like this. Now it doesn't really matter how you get from this trinomial to these two binomials. This method of grouping or using a diamond, whatever you want to refer to it as, is a method that I like to teach. But if you can get from here to here with fewer steps, that's great. Go ahead and do that whenever you can. Sometimes some problems are easier than others, but it's good to have a method to do the hard ones, so you should practice some of the problems this way.